Okay, this is our third page. This one's called Circuits and Symbols, and this is where we get into the idea of putting electrical components together to create a circuit, and also being able to define certain symbols that you see so that you know what they mean when you see them. So I'm just going to read through the front and then we'll do the back together. Electricity works a lot like water. Often imagining how water would work in a circuit will tell you how electricity will work as well. Electricity flows through circuits, paths of conductors, which are usually wires. Any break in the circuit will cause the circuit to fail, just like a break in a pipe lets water leak out of a system. I'm actually going to see if I can highlight here. Might be easier. A break in a circuit is any spot where an insulator is in the way of electricity's flow. Paper, plastic, or even an air gap can keep electricity from flowing. A closed circuit has no breaks. The light lights up. So closed means it's on. An open circuit has a break in it. The light will not light up. So you can see the break right here. This has no break. Then we go to the circuit diagrams. Circuit diagrams are a shortcut method of drawing circuits. They don't need to be perfectly drawn, but they can be drawn wrong. So notice that for the battery, it won't let me do that. Let's see. Let's get rid of that. Well, I guess I'll leave that. So notice for the battery, the bottom T, I guess we'll call it, is shorter on the sides than the top T. And the capacitor is different because it has the bottom and the top T that match. So you want to make sure that when you make a battery, or you see something that kind of looks like it might be the symbol of a battery, that it doesn't have the exact same size in the top T, because the battery, like I said, either the lower or the top should be larger on the horizontal end. The diagram right here for your light bulbs, the diagram on the right is a faster way of drawing the circuit on the left. So instead of drawing the whole battery, you can draw, again, a line right here, kind of what you see here. This should kind of match that. Light bulb, again, easier to draw like this than like this. Resistor, easier to draw than this. Switch, right here, easier to draw than this. That's why they come up with the symbols. Notice the direction of the battery, which is important. This actually has the flow of electrons. I'm going to change over to the pencil here. Will actually move this way. So this being your positive end and this being your negative end. So if this was closed, the light would light up, hopefully, it should. The resistor flows or slows down the amount of energy or electricity that's going through the circuit so that the light bulb won't like go out or break the filament and it won't break. So if you think of the word resist, it means stop. So it doesn't stop it completely, but it does slow it down. Now, if your resistor is way too strong, it could stop it completely. But usually, if you figure things out the right way, or you're given the right components, it should work just fine. Electrical symbols, here they are on this chart here. You have a wire shown like a line. This is where electricity flows through. Its equivalent is a pipe that water would flow through. A battery looks like this, positive, negative, pushes electricity through the circuit. And it works like a pump. So it's pumping out electrons from this side, pumps through and back. A light bulb symbol looks like this, lights up, resists electricity. So again, it's going to kind of like take some of the electricity, or it slows it down a bit, stops it a bit. No equivalent. Switch is represented by this symbol, turns electricity on and off because it either closes the system or opens it. And it can be equivalent or equal to like a valve on the water. You shut your faucet off. That's like a switch. Resistor shown like this, and resists or slows the flow of electricity. And this would be a restriction in the pipe. Maybe it gets narrower so the water can't pass through as quickly, or maybe usually on the bottom of a faucet there is a screen that again kind of slows down or makes the water flow out a particular way. And over here we have quantities, 3 quantities of a circuit. And this kind of explains the 3 quantities or 3 variables that you want to know in order to be able to solve for voltage, which actually usually just gives you the voltage on the battery, solve for current, which is measured in amps, and solve for resistance, which is measured in ohms. And those 3 variables or quantities of a circuit are known as Ohm's law, or the relationship between those 3 are known as Ohm's law. These 3 quantities are linked in any circuit. Change one of them and one or both of the others will change. So voltage pushes electrons. So the higher the voltage, the more electrons will be pushed through. Smaller the voltage, like when your battery is almost dead, barely any electrons will push through. And this is an older paper or worksheet because you'll notice that it's flowing in this direction, but it's actually correct to say that electrons flow out the negative side. And then it says currents flow through. So I guess honestly, this should be the positive side, this should be the negative side, and they should be flowing in this direction right here. And then here is the picture of the resistance where you can see how it narrows. It gets way narrower down here so that the flow of electrons is lessened quite a bit. Hopefully without stopping it completely. So they give you that first page to look at, and then right here they want you to now match everything up. So we'll do it the same way we did before. So again, I like to start with, I'm going to use my pencil here. I like to start with the definition and match it up with the word. Slows down the flow of electricity. Because I just read that, I know that that is resistance. And so this is A. I'll write it over on the side. A shorthand way of drawing electrical circuits, a circuit diagram. A circuit with a break in it, no electricity will flow. This would be an open circuit. Pushes electricity through a circuit. That's going to be your voltage, like your battery. Electricity can flow through this. Did I use everything yet? A closed circuit. Oh, yes, that is E, closed circuit. And finally, the flow of electricity through a current, right here. You can think of like a river too, if it has a strong current or a weak current. That would be like how much electricity is flowing through it. So this is F. Okay, I'm going to go, I guess, right down here. Which of the following are correct? So remember, the smaller side is the negative side, the larger side is the positive. So B is correct. And then right here, this is just the opposite of what we see, so this is correct. So this is incorrect and this is incorrect. Label the diagram. Resistor. And then we have light bulb. And then we have wire. And then we have right here, we have, this is your, what is this called? This is your battery, or I'm sorry, your voltage. Battery. And this is your switch right here. Okay, we'll just check ourselves. And yes, looks good. All right, match the electrical component with the water component and diagram symbol. So you're supposed to like match it with the equivalent. So the valve is like a switch. So this goes here. The pipe is like a wire, so this goes here. No equivalent for the light bulb. Resist flow is your resistor, and your battery is like the pump. And then this is your wire, so this goes here. This is your light bulb, so this goes here. This is E. This is your resistor, C is your resistor. Your battery is B right here. And then your switch is right here at D. Used to create radiant energy. Radiant means that it radiates, that you can see it, or it can radiate energy. You could think of radiator. You could feel the heat come off of it. You don't see it, but they're talking about a light bulb here. Pushes electricity through a circuit. That would be your battery. Can turn electricity on and off. That's going to definitely be your switch. Slows down the flow of electricity. That is definitely your resistor. And allows electricity to flow. That's your wire. Now it says to draw a circuit diagram starting on the left with a battery. So now they want us to show what we know. Make sure it's a closed circuit connected with wires. So I'm going to start the longer side there, the shorter side here. I'm going to go around and then I'm going to make a little switch. This is a little messier because I'm trying to draw this freehand. And then I'm going to make the resistor. Sorry, that is kind of messy. I'm going to have it go over here. And then I'm going to make the kind of funky little switch there. And okay, it's kind of ugly. All right, so this is my plus side, this is my negative side. And does it tell me to label it? Starting on the left, draw a circuit diagram. Closed circuit, so I'm just gonna close it. This is my switch, resistor, bulb, battery, wire. And what way does the electricity flow? Remember, it's going from the negative side over. Okay. And that is that because we really can't do the in-lab part because we don't have the material. You could probably figure it out, but I know I told you didn't have to do that part. And we're done with that. So study it, go over it, know it, ask me any questions if you don't understand it.